Okay, lesson 3 is on rational exponents. This might be a little strange at first, but it's probably because of the way you've always seen roots written. So if I'm looking at the square root of 9, you've been told, now maybe you'd write plus or minus 3, but the square root of 9, when you were younger, your teacher would say, oh, the square root of 9 is 3. Something that is missing from that, which you might have noticed on an iPhone scientific calculator, is that there could be a little 2 there. That's the square root. What two numbers multiply by themselves to give you 9, two numbers that are identical. So we could also see something like this, which you might have seen before. The cube root of 8. That's asking you what number multiplies by itself 3 times to give you 8. And so the answer to that is 2. You might notice on an iPhone especially that even the square root button always has a little 2 there, and the cube root button has a 3. On an iPhone you might notice a button that looks like this as well. So this is kind of saying, yeah, we could have square roots, we could have cube roots, we could have fourth roots or fifth roots of a certain number. So if it was a fourth root, what number would multiply by itself 4 times to give you this value? We're just not used to seeing it. Another way on a scientific calculator, you might see the button look like that. Or maybe there's an X here and a Y inside, but it's just kind of pointing out that this number out here doesn't always have to be a 2. You're not always just finding the square root of a certain value. What's also strange is that this 9, the square root of 9, could also be written with a fractional exponent. So that is actually the same thing as what you see up above. That answer is also 3. Those are the same. So when we have a fractional exponent, we might think of this 2 is the number that would, in the denominator, is the number that would come back out front here, and that is what root we're looking at. So if I was looking at 8 to the 1/3, that's the same thing. That would be 2. So this little rule here is just explaining that. So the nth root of a is the same thing as a to the 1 over n, or to the power of 1 over n. A little weird at first because it's just a new sort of rule or definition that you're not used to, but really it's not too bad to get used to. Here, example 1, same kind of questions that we were just looking at. 9, I guess what I would do when I see this is I would say that that is then the square root of 9. And this 1 actually could become this exponent out here. But anything to the exponent 1 doesn't really change the value that we have. So we know that answer is just 3. And here, 8 to the 1/3, that is the cube root of 8 to the exponent 1, but I mean, we usually don't write that exponent 1 down because it doesn't change anything. When the denominator is a 3, when you have a rational exponent or a fraction as an exponent, the denominator is the root that you're looking at. So this is kind of a weird question, but this is asking you what is the 15th root of 1. So that just means what multiplies by itself 15 times to give you 1, and the answer is still just 1. You can use your calculator to type these in. You could actually use this value, the 15th root of 1. You could even write 1 to the exponent and put brackets around your exponents. 1 to the exponent, 1/15 is 1, just if you wanted to check. When there's a negative value, that would go underneath the square root sign as well. So this is asking you for the 5th root of negative 32. That might seem like a really hard question, but 5 is an odd number. So I know that the 5th root of 32 is 2. So you might have to use that button on your scientific calculator like this. However you have to practice to learn to type this in, this value would become the 5, and underneath the square root sign is the negative 32. I know the square, or the 5th root of 32 is 2. 2 times 2 times 2 times 2 times 2 is 32. But an odd number of multiplications would give you a negative. So if I had a negative 2 to the exponent 5, I should get negative 32. So you can check your answers and kind of work backwards. You could type this in on your calculator. With the rational exponent, you could put brackets around it. So if you did negative 32 on your calculator to the exponent bracket 1 divided by 5 bracket, you should also get negative 2. But this is what it's asking you for, the fifth root of negative 32. Hard to do some of them without a calculator. A little bit of a step ahead now. If your fraction doesn't necessarily just have a 1 in the numerator, what happens is that we still in the denominator, this means it's the nth root of a, but that is to the exponent m. I think I'm more a fan of this way to write it though. I've just always learned it this way. The n becomes the root and the m is the exponent. And I tend to write it outside. I'd much rather find the nth root of a first and then to that exponent m would be an easier way to find your answer. So a few of these, this is just like, what kind of math is making sense to you? 2 over 4, hopefully you might make that just 1 over 2 because you can write it in lowest terms. And that's just asking you for the square root of 9 to the exponent 1. And I do tend to write that exponent on the outside. So that's just 3 to the exponent 1, which is just 3. This one over here, we have learned about exponent rules, and we know that you multiply the exponents when the exponent has an exponent or a power of a power. Maybe we would write that first as 64 to the 2 over 12. But I could also write that and simplify that to lowest terms. That's 1 over 6. So really, that's asking you for the sixth root of 64. And you're going to have to practice with your calculator if you're not sure, to the exponent 1. The sixth root of 64 is 2. 2 times 2 times 2 times 2 times 2 times 2 is 64. But I am thinking that you're going to practice on your calculator, figure out how to punch that in so that you get 2. And there are scientific calculators online if you don't have one at home. You can, Desmos has a scientific calculator, or there's even a scientific calculator, I think, just when you Google. So I'm hoping it has different root buttons. I'm not sure. So this one here on the back of the page, I have, that means I'm taking the cube root of negative 216, and I tend to always put this squared outside. Sometimes people put it inside. Then you would find a bigger number first and then find the cube root of that. I think this is easier to find the cube root of negative 216 first. So I can type that into a calculator if I'm not sure. The cube root of negative 216 is negative 6. And then I square my answer because then I can do that in my head, that one. And I just get 36. This one, D, I have negative. So this is bringing back some of the rules that you've already learned, which hopefully you were finding kind of easy. But now I have negative exponents. Well, you can never leave your answers, or you should never leave your answer with a negative exponent. So right away, I imagine that these are fractions with a denominator of 1. And I'd like to write the reciprocal. So this is 1 over 64. And then instead of the exponent being negative 1/6, because I'm using the reciprocal, it's just 1 over 6. Plus, and then I'm going to use the reciprocal again, 1 over 64. And then this would become just to the positive 1/2. Since I'm using the reciprocal, my exponent becomes positive. So 1 over 6 as a rational exponent, this would be the sixth root of 1 over 64 to the exponent 1. And this would be the square root of 1 over 64, exponent 1. So the sixth root of 64 is 2. I think we've seen that already. So this is 1 over 2 plus the square root of, so think of it this way. The square root of 1 is 1. The square root of 64 is 8. So I should have said it over here too. The sixth root of 1 is 1. The sixth root of 64 is 2. So you would do the numerator and the denominator separately. And then this is just math. So now I notice that I don't have a common denominator. So maybe I'd like to write 4 over 8 instead of 1/2, multiplying the top by 4 and the denominator by 4. So I get an answer of 5 over 8, and I've simplified as far as I can go. If you have some variables, same rules apply. This is just, we've learned about multiplying powers that have the same base. So even if you have a rational exponent, that's okay too. We can have a fraction, but we would add our exponents. So if I had an exponent of 1 already, I could have m to the 1/3 times m to the 3/3, because 1 is the same thing as 3 over 3. So maybe I would have m to the 4/3, and that is simplified. Just a different way to think of having these fractional exponents, and you can still follow the same rules that we've already learned. And then the last one is 9 over 16 to the negative 3 over 2. Okay, I see the negative exponent right away. I want to use the reciprocal of my fraction, and then my exponent becomes positive instead of negative 3 over 2. I flip my fraction upside down. Now, this means the square root of 16 over 9 to the 3rd. So that's where these, in this, the numerator becomes the exponent, and it kind of stays where it was. It's still just the exponent, but the denominator, now we have the second root, or the square root. So we would do the square root of 16, which is 4, and the square root of 9, which is 3, but now that is still to the 3rd. So with fractions, the numerator is to the 3rd, that's 64, 4 to the 3rd, and the denominator is to the 3rd. So 3 times 3 times 3 is 27.